Hello, my name is Theron White, and this is Group 21's demo video for Phase 2 of CSE412. To start this video off, I'm going to give a quick refresher on what our application is and our ER diagram. Then I'm going to hand it off to Isabella, who will walk through our DDL translation and actual table structure in pgadmin. After that, Kushagra will demo the data population in pgadmin and discuss some of the decisions we made in populating our data. And lastly, Ty will go over the current queries, select, insert, update, and delete. So to recap from the previous phase as to what our application is, we have decided to develop a local food price tracker as a web application where users can compare and track grocery prices across multiple stores. The app will consist of many features including region-based product searching, shopping list creation and management, price history tracking and trend analysis, and coupon integration and management, to name a few. Now let me quickly review the ER diagram from phase 1 of the project. So at the core of our ER diagram, we have store and product entities connected through an offers relationship. Stores have attributes like store ID, name, and zip code, while products include product ID, name, category, and current price. Users will interact with the system through several relationships. They use products, create shopping lists, and set price preferences. The shopping list entity tracks what users want to buy, product preferences sets up price alerts, and price history keeps record of how prices change over time. We also have a coupon entity that connects to products and stores, offering discounts to users. This diagram shows the key relationships present in our database that Isabella will now go over.
Hi, I'm Isabel Swanson, and I'll be covering the ER to relational model transformation. So, in demonstrating how we transformed our ER diagram and conceptual model into a functional SQL database schema, the implementation began with creating 7 tables that support the core functionality of price comparison and tracking. So first we have the stores table that contains information about the retail locations, and the core 3 that we will be using are Target, Fry's, and Amazon. And each store has a unique ID, name, zip code, and API connection details for data synchronization. The products table is central to our application, which stores all the grocery items with descriptions, categories, prices, and image URLs. And then notice how we've implemented the store ID as a foreign key to maintain the referential integrity. And then we also have the users table, which maintains customer information, including email, password, zip code, and budget preferences. This allows for a personalized shopping experience so that they can save lists and create preferences if they want to notify or be notified about a certain item being placed on sale or at a lower price. And so with that, we have several supporting tables. So we have the shopping list for the user created list, as I mentioned before, product preferences for price alerts, price history for price history for trend analysis, and then the coupons table for the available discounts. And so we've used the appropriate SQL data types throughout: serial for auto incrementing IDs, varchar for text with defined lengths, decimal for precise price values, and then also timestamp for date tracking. Foreign key constraints also ensure the data integrity across the system is preventing orphaned records if a parent record is deleted on accident or deleted in general. So in general, this database structure efficiently supports our application requirements for our desired uses of price comparison, historical tracking, and then also the personalized user features while maintaining the data integrity.
Hi, my name is Kushagra, and I'll be going over how we populated the data in our database using CSV files. So we basically chose CSV files because it is a much faster way of transferring all of the data that we collected for our grocery price tracker. It would basically allow us to update the data in real time and would allow us for a more faster and a more convenient way of transferring all of the data into the database itself. So right now in front of you, I have commented out most of the commands, but here you can see that these commands were used to create the tables according to the required data types as well as the columns. I will show you how we created the table by uh, running this command. I have deleted the coupons table and I'll just make it again and transfer all the data into it again. So as you can see, the query has returned and we have a new table now. There you go. We have coupons now. And then to test it out, and there you go. As you can see, these are the coupons and these are the first 10 occurrences of coupons table. And we chose CSV for its convenience and we used the copy command instead of insert because adding all of the data one by one would have been a very tedious process and not efficient at all. And as you can see, this is how we created the database. Thank you so much.
Hi there, my name's Ty. I'll be going over the queries on question number 3. The very first query is our select, which is doing retrieve product from a specific store. It's pretty much doing is that retrieving all product available in store ID number 1, also filtering the product table to only show relevant items, like displaying their names, categories, prices, and product IDs. Move on to the second select query, which is product above $50 order by price. What this second query is doing is that it finds all product that cost more than $50 and sort them from the highest to lowest price using order by current price. Ascending. All right, so our next is the insert query. Is what we doing adding a new user. This query pretty much is doing the inserting statement as a new user to our database with an email password and their budget of $50 and also the zip code where they're living. For example, in this query, which is 10,000. Move on to our update query. This one is in general is going to increase the prices for meat categories. The query itself updates is going to increasing the price of our product in the meat category by 10 times. The where clause ensure that only meat products are updated.
And the last query for us to go over is the delete query, where you can see that we successfully deleted the history ID of 29 from the price history table. So to summarize, our database successfully models the relationships between stores, products, and users, and the schema supports all core functionality for price tracking and comparison. Thank you for watching our demo for phase 2 of the project.